So if we put these together, it's going to make carbon dioxide. These are molecules. And we know this because we read about it, we studied the science. Someone had to actually invent this at first, though.
Did.
Okay, let's see if we can get a reaction here where we put the vinegar in with this. Have you got your glasses on?
I do.
Okay, well then you can pour it. No, I'll do it. Here we go. Here goes the vinegar. Watch the soda and see what happens.
I see it bubbling.
Can you see that it's bubbling?
Yep.
Okay, I'm putting the lid on here, but I'm doing it kind of loose so that while it bubbles, it will push the air out and we'll get some carbon dioxide stored in this flask so we can do something interesting with it. So much for the vinegar.
Okay.
So much. We should have some carbon dioxide there. Now, the next thing we're going to do is we're going to get to the zinc. If you put hydrochloric acid with zinc, then you make hydrogen.
That's awesome.
This is a laboratory way of producing hydrogen. So let's give it a try. No, let's give it a go. Let's give it a go.
There is no try.
That's what our Brits say. Let's give it a go. Okay, here we go. Acid in on the zinc, and I can see some bubbles there. I'm going to go ahead and put a cork on loosely again. See if we can build up some stuff. Can you see some little bubbles there?
I can.
Little bubbles.
It's getting excited.
So we're making some hydrogen in there. So what are we doing? We're actually reacting the metal with the zinc, making zinc chloride, which is a salt. Yeah, it's reacting, a chemical reaction. Okay. They're becoming, it's like they're getting married. Yeah, it is, seriously. And so the zinc is becoming zinc chloride, which if we dry it out, it's a salt. And the hydrogen that is in the hydrochloric acid is forming this hydrogen chloride, HCl. The hydrogen is coming out as gas. Now look how it's bubbling. Can you see it's better? I don't know if we can get a good close-up on that. So that's bubbling. Bubble, bubble, bubble. We are making hydrogens, and they are pushing out this little cap here, and hopefully we're pushing some of the air out if it gets too out. Now we've got this last one. Has anyone ever experimented on themselves with hydrogen peroxide?
Yes.
Have you ever noticed that if you get a cut or something and you get some hydrogen peroxide and you dab it on your cut, it fizzes? Bzzz. That is the same experiment I'm going to do now. Do you know what that fizz is?
Tell us.
I think it's germ killerator.
I think so too.
No, it's oxygen. When hydrogen peroxide comes in contact with certain chemicals, one of them being potassium permanganate, another one being yeast, another one being your skin, it reacts and the hydrogen peroxide breaks down into oxygen and water. So we're going to try that. I'm going to use the potassium permanganate here and our hydrogen peroxide. Are you ready?
Yes.
Here we go. You have glass on. You could hold this. No, we want to see it. Can you hold it up here? There you go. Isn't she good at this? You know, other researchers spend a fortune buying a little machine to hold that, and we get it for free. Here we go.
Okay.
Here we go. Here we go. Let's see what we got. We poured it. Oh, look at that. Oh,
Look at that.
That looks very dangerous. Let's cap
like
it.
Somebody's brew.
It is cooking, isn't it?
It's red.
So we are now releasing the prisoners. And what was prisoner in hydrogen peroxide? Oxygen. We're letting the oxygen out. Look at that. There it goes. Now, that's just all basic, you know, in your household science. But scientists are very curious, people are. And we want to know, is this really carbon dioxide in here? Is this really hydrogen being formed?
Yes, we want to know.
And how could we know if it's hydrogen? And what about this? Is this really oxygen that was made? How could we know? And that's where you have to get the spark of an idea. I have the spark of an idea, and I now have candle.
Yes.
That is called a flame, right?
It is.
Yeah, in science and engineering. Okay, so I have what's called a splinter. To me, it looks like a stick, but you know, they call it a splinter. And if you light the splinter on fire in the flame, it will burn. Can you see the burning? You blow it out, and you have what's called a glowing splinter. Yeah, isn't that great? A glowing splinter. Now, one of the tests that scientists learned they can do, if it's just glowing because the fire's gone out, if you put it in pure oxygen, it should burst back in flame. Will it?
Let's find out.
We could find out. Here we go.
Yep.
Ooh, look at that. Try that again. So it's just a glowing splinter. It's not burning in the air. What will it do in the oxygen? Whoa. Lo and behold. Sorry. Should we see if we got enough for one more go?
Let's do it.
All right.
Yes.
One more go
One
here.
more go. Yep, we do.
So that definitely is oxygen. But how will we know if we have any hydrogen here?
That's how we know.
Okay, we
Much more
definitely have
exciting
hydrogen, don't we?
I love it. It lets you know it's there, doesn't it?
Hydrogen really gets me going, and always has. Oh, I love
I love his
hydrogen.
face.
But now, how are we going to test to see if we have carbon dioxide? It's probably making this heavier. See if it feels heavier to you.
Yeah.
Oh, yeah. No, you can't. Carbon dioxide is a colorless gas. It's odorless. You can't smell it. Of course, the cap's on, too. That makes it harder. But it's heavier than air, which means if I pull this cork off and pour it, it would be invisible, but it would come out and would go down to the ground.
I'd love to see that.
Gradually, it would diffuse into the air. But carbon dioxide won't burn. So if we really made some carbon dioxide, I could pour it over that flame and it would come flowing out. It'd be invisible, but it'd come down and it would smother the flame.
Okay, let's try
Should we
it.
try it?
Yes.
We need science music. Go ahead and make some.
Dun, 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 dun. Oh, you want happy music?
Okay. Here it goes.
Still there. Oh, there it is. It's gone.